At exactly the moment everything stops, you find out who actually understands how things move, not who has the most power, not who has the biggest machine, but who sees the system underneath the problem, and most people never even realize there is a system at all. For 3 days, an entire rail line was frozen by a single failure, hundreds of tons of steel sitting motionless on a track that everything depended on, shipments rotting, pressure building, experts arriving with bigger engines, more horsepower, more force, and every attempt making the problem worse, not better, because they were all solving the visible problem instead of the hidden one. The official explanation was simple: the machine was too heavy, the failure too severe, the only solution was more equipment, more time, more waiting. But that explanation quietly ignored something critical, because weight was not the real resistance, and force was not the real limitation. The system itself was misread. What nobody said out loud is that large systems don't usually fail because they're too strong, they fail because they're being pushed in the exact direction they're designed to resist, and that is the hidden pattern most people never learn to see. The attempts followed protocol: direct force applied directly along the line of motion, maximum output, maximum strain, everything aligned. And that alignment is exactly what locked the system in place, because when resistance is perfectly matched, more power doesn't break it, it reinforces it, it stabilizes the failure. You could feel it in the way the machines responded: cables snapping under tension, wheels spinning without progress, energy converting into noise, heat, and damage instead of movement, a clear sign that the system wasn't being overcome, it was being fed. The assumption was that progress comes from increasing intensity, but in mechanical systems, and in most real-world systems, progress often comes from changing direction, and that distinction is where almost everyone fails. The man who eventually solved it did not bring more power, he brought a different model of the problem, and that is the entire difference, because once the model changes, the solution becomes obvious, almost simple. He understood something that isn't written in manuals but is repeated everywhere in nature and work: that resistance has shape, and if you study that shape instead of attacking it, you can collapse it with less effort than brute force ever could. Instead of asking how to overpower the blockage, he asked how the blockage was structured, where it was strongest, and more importantly, where it wasn't. That shift alone reframed everything. The system wasn't a stuck object, it was a locked alignment, and locked alignments don't break from pressure, they break from disruption. So instead of pulling forward, he redirected the force sideways, not randomly, but precisely, introducing load into a dimension the system wasn't built to resist, and that is where the mechanism changes. When force is applied off-axis, it doesn't just push, it destabilizes, it creates asymmetry, and asymmetry is what allows motion to begin. The method was quiet, almost unimpressive at first: a slow build of tension instead of explosive power, continuous force instead of pulses, because systems under stress respond differently to rhythm than to impact. Sudden force triggers resistance, steady force rewires it. That is why the earlier attempts failed: they shocked the system repeatedly, reinforcing the lock each time, while the final approach dissolved it gradually, letting internal constraints shift until movement became possible. And when it happened, it didn't look dramatic: there was no explosion of motion, just a subtle change, a slight adjustment, the kind most people would miss, but that small shift meant the system had already lost, because once resistance changes direction, it stops being resistance and starts becoming motion. From there, everything accelerates naturally, not because more power is added, but because the system is finally aligned with movement instead of against it. This is the part most people misunderstand: the breakthrough didn't happen when the machine moved, it happened when the force was applied correctly, the movement was just the result. And once you see it, you start noticing the same pattern everywhere: in business systems that stall under pressure, in financial systems that collapse under leverage, in health systems that worsen under aggressive intervention, in every domain where people mistake intensity for intelligence. The timeline is always the same: initial failure, escalation of force, increasing damage, then a quiet shift in approach that suddenly makes everything work, and it always looks like magic to those who miss the underlying structure. But it isn't magic, it's pattern recognition. And once you understand that pattern, you realize something unsettling: most problems persist not because they are too big, but because they are being approached in the exact way that keeps them locked. The expansion of this idea goes far beyond machinery, because any system with constraints behaves this way, whether it's a market, a body, or a network, and the people who win in these environments are not the ones with the most resources, they are the ones who can see the hidden geometry of resistance. That's why small inputs sometimes create massive outcomes while massive inputs create nothing at all, because scale doesn't matter if direction is wrong. And the final realization, the one that changes how you look at everything, is that power is rarely the advantage people think it is, understanding is, because power without understanding amplifies failure, while understanding reduces the need for power entirely. Most people will spend their lives pushing harder against problems that are designed to resist them, never realizing that a slight shift in angle would have solved everything in a fraction of the time, and that is the quiet truth behind systems. They don't reward effort, they reward alignment, and once you see that, you can never unsee it. Most people think that was the end of the story, a clever solution, a moment of ingenuity, something impressive but isolated, but that interpretation misses the deeper layer completely, because what actually happened there wasn't a one-time fix, it was a demonstration of a rule that quietly governs almost every system you interact with, and once you understand that rule, you start seeing inefficiencies everywhere that others mistake for inevitability. The real hidden system is this: resistance is rarely absolute, it is directional, and direction determines outcome more than magnitude ever will. When a system locks, it is not telling you that movement is impossible, it is telling you that movement in that specific direction is impossible, and that distinction is where leverage is created. This is why highly optimized systems often fail catastrophically, because they are built to perform perfectly under expected conditions, but they become fragile when those conditions shift even slightly, and the people managing them respond by increasing pressure instead of changing orientation. You see it in supply chains that collapse under demand spikes, where adding more throughput only creates bottlenecks downstream. You see it in financial markets where injecting more liquidity inflates instability instead of resolving it, and you see it in personal health where aggressive intervention can worsen the underlying imbalance because the system is already overloaded in that axis. The mechanism is consistent across domains. Force applied along the axis of resistance amplifies the lock, while force applied across it disrupts the structure. What makes this powerful is that it flips the entire strategy most people rely on. Instead of asking how do I do more, the correct question becomes where is the system not prepared for force, because that is where minimal input creates maximum effect. And this is why small, seemingly insignificant actions can outperform massive coordinated efforts, because they operate in dimensions the system hasn't fortified. Over time, people who understand this stop competing on strength entirely, they compete on positioning, on timing, on angles that others ignore, and that is where disproportionate results come from. The results don't just appear faster, they appear cleaner, with less damage, less wasted energy, and fewer unintended consequences, because the system isn't being fought, it's being redirected. And once that shift happens, timelines compress dramatically. What should have taken days resolves in minutes, what seemed immovable becomes fluid, and observers often misinterpret it as luck or genius, when in reality it's just alignment with the system's hidden structure. This is also why most advice fails people, because it focuses on increasing effort rather than refining approach, pushing harder, working longer, scaling bigger, all of which can trap someone deeper inside a resistance system instead of freeing them from it. The expansion of this principle becomes almost unsettling when you apply it broadly, because it suggests that a large percentage of struggle is self-created by misunderstanding system dynamics, not by lack of capability or resources. Entire industries are built around treating symptoms of resistance rather than understanding its geometry, which is why solutions often feel temporary or incomplete. But once you internalize this, your behavior changes in subtle but powerful ways. You start pausing before applying force, observing before acting, testing angles instead of committing fully to one direction, and that alone puts you ahead of most people operating on instinct. The emotional shift is just as significant, because frustration decreases when you realize the system isn't against you, it's just responding predictably to how you're interacting with it, and that predictability becomes an advantage instead of a barrier. In the end, the story isn't about a machine being moved, it's about a perspective being corrected, a reminder that reality is structured, not random, and that structure can be understood if you're willing to look beyond the obvious. And the final layer, the one most people overlook entirely, is that once you start seeing systems this way, you also start seeing where others are stuck, where they're applying force in the wrong direction, where they're reinforcing their own resistance without realizing it, and that awareness gives you something far more valuable than strength. It gives you control over outcomes that once seemed out of reach, not by overpowering the system, but by working with it in the exact way it quietly demands. And once you begin to operate that way consistently, something else happens that most people don't expect. You stop reacting to problems as events and start reading them as signals, because every failure contains information about the structure you're dealing with, every point of friction is feedback about direction, not just difficulty, And the people who extract that information quickly are the ones who appear to move effortlessly while everyone else exhausts themselves. What looks like patience from the outside is actually precision, because instead of rushing into action, you're mapping the system in real time, identifying where force is absorbed, where it's redirected, and where it might finally translate into movement. This is why controlled, steady input often outperforms aggressive bursts, because systems adapt to shocks but yield to sustained, intelligent pressure, and that difference is subtle but decisive. Over longer timelines, this compounds into a completely different trajectory, where small correct moves stack into large outcomes while large incorrect moves cancel themselves out. You start to notice that most bottlenecks aren't physical limitations but structural ones, invisible constraints created by alignment, timing, or sequencing, and once those are adjusted, capacity suddenly appears where none seem to exist. In practical terms, this changes how you approach everything, from building income streams to managing energy, from solving technical problems to navigating uncertainty, because instead of asking how to increase output, you're constantly refining where and how that output is applied. And the paradox becomes clear: the more precisely you understand the system, the less effort you need to exert, not because the work disappears, but because waste disappears. This is also where discipline takes on a different meaning. It's no longer about forcing yourself through resistance, it's about resisting the urge to apply force blindly, holding back just long enough to identify the correct vector, because once you commit, you want that effort to count. The people who ignore this keep cycling through the same pattern: push harder, meet resistance, escalate effort, experience burnout or failure, then repeat, never realizing that the system is responding exactly as designed. Meanwhile, those who adapt begin to operate almost invisibly, making moves that don't attract attention until the results are undeniable, because alignment doesn't look dramatic, it looks obvious in hindsight. And that's why these moments feel so powerful when you witness them, because they reveal something most people sense but rarely articulate: that the world is not primarily a contest of strength, but a landscape of structures, and once you understand those structures, you're no longer guessing, you're navigating. The final shift is internal. You stop measuring progress by how hard something feels and start measuring it by how effectively it moves, and that recalibration alone separates people who stay stuck from those who consistently advance. In the end, the lesson isn't just that a different approach works, it's that the right approach was always available, hidden in plain sight, waiting for someone willing to look past the obvious and engage with the system as it actually is, not as it appears to be. And once you start doing that, you realize something that quietly changes everything going forward: the real advantage was never more power, it was always better understanding of where to apply it.